So whenever we have similar type of objects, that time we go for inheritance. In this case, if you see plane, passenger plane is a similar object of plane class. Then only we are going with inheritance. What if you have different type of objects? How do you relate them? That's what called association. So let me note down what is association. When somebody asks you in interview what is association, it's a linkage between two classes, two non-similar classes, which will turn into objects. So when you actually create the object, one object will contain another object inside. So how do we represent the association in UML notation? Unlike the inheritance, where we actually show a kind of hierarchical relationship, association is shown as connection between two objects like this. This is how we represent. So here we say A and B. So A class is containing object of B class. Now how many objects of B class can be contained inside A class? That we tell using cardinality. So if I say my cardinality is 1:n. Don't confuse with the database cardinality. That's a different concept. So 1:n means my class A can contain n number of objects of class B. That's called association. Why do we need it? Everything has a purpose. If we are doing association, why exactly? What is the need of association? The need of association is sometimes we need to modularize classes. So you will not develop the complete functionality in one class. Instead, you will develop it in small piece of classes. And then in order to run the functionality, we associate all the classes. Let me take an example. Let's imagine I have an airplane. Can anybody tell me some components of an airplane? What are all the components of an airplane?
Have wings, engine.
Very good. What else? Come on, we saw a lot of TV channels, lot of TV programs where they discuss about airplanes. We have seen personally airplanes. There are a lot of components an airplane have, which a layman person will also know. I just need three. First is engine, next is what?
Wings.
Very good, superb. Just one more, guys. Come on. We are engineers.
Turbines.
Turbines, very good. That comes under engine.
Yeah.
Right. Turbines is the integral part of engine. Engine in turn will contain, turbines, engine fan, fuel pipes, combustion chamber, the kind of, strokes, all these gears will all be part of an engine. What else? Come on, just one more component. There are a lot of them.
What about seats?
Seats, yes. But that's an integral component only of a passenger plane, not a normal plane.
Oh yeah.
What else?
Receivers.
Receivers, like or transponders, which sends the signal to another plane.
Black box. Black box, we can
Super,
say.
very good example. See, when we think about it, we get lot many. Black boxes, receivers, transponders. Even passenger is also an integral part of a plane, right? A
Yeah.
passenger is part of a plane. He or she sits inside a plane. That's also part of a plane. Okay. But these are all three components which are the most important ones, which are very, very tightly coupled with a plane, right?
Yeah.
Can you see a wing flying without any plane in the sky? No. A wing cannot fly on its own. It needs the complete infrastructure of plane. It has to be attached to a plane, then only the entire plane can fly. Can you see an engine flying on its own? No. Can you see a black box flying in a free air? No. So these are all the most integral part of a plane. So this is the must-have relationship with the plane object. This type of relationship is called as composition. It's a type of association. Association is of two types. First is called composition. Second is called aggregation. So composition is a must-have relationship between two objects. So here the wing, black box, engine, they all are again some classes and they will produce objects. The objects produced by these classes will actually be integrated with the plane object. It's a must-have relationship, which means whenever you create a plane object, all these objects will automatically be created in the simple terms. Now coming to a should have relationship, which is nothing but your passengers. The passengers are nothing but should have relationship, which means a plane can fly without passenger, but ideally it should fly with passengers. So it's a loose binding between two objects. It's called aggregation. Understood the difference between aggregation and composition? Any doubt?
But composition is a mandatory and aggregation is optional.
Optional, yes. Also, it is not mandatory to have an object of passenger inside a plane. A plane
Okay.
can even fly without passenger, but it cannot fly without these things, engines, wings, black boxes. So automatically these objects should be created, must be created whenever you create a plane object. But when you create a plane object, it is not mandatory to have passenger object inside it. Now, can anybody tell me relationship between passenger object and plane object? What should be the relationship? Cardinality?
One to many.
One to many, very good. Because one plane can have many number of passengers flying. Very good. You understood the concept. Super. So how do we actually you achieve this? So we actually what we do is we bind these objects with another object, plane object, and now whenever plane needs to fly, it needs to send a signal to the engine that start the engine. So starting of engine contains so many other steps like it will ignite, it will start the fuel supply, it will generate the thrust, it will start the starter, it will generate some spark, then the engine will start burning. All these are integral part of engine that engine should take care. We should not take care. The plane should not worry about that. So that's a separate class itself, engine, which has its own responsibility, starting the engine, stopping the engine, increasing the thrust in the turbine, losing the thrust, changing the different things, different parameters, logging the parameters. All these are part of a engine class. not plane. Plane is not responsible for doing that. Plane will just inform the engine, and it's up to the engine to take care of things. Similarly, wings. On the wings, if you have seen, there are some components mounted which takes care of your altitude information, which takes care of your direction information, which takes care of your speed of speed of air in the sky, what speed you are going in the sky. It takes care of direction of nose. It takes care of ailerons. It takes care of your elevators to lose the height, to increase the height. In case of landing, it takes care of maintaining a balance. All these are the functionality of a wing. Okay. So this is all the functionality of a wing. I should not even worry about that as a plane. I should just tell the wing what needs to do. Wing should know how it has to do. So there is a clear responsibility on the classes and objects in OOPS app or in any OOPS if you say. And that's the real power of OOPS, where you divide the functionality into sub-modules and connect them together later. That's how we do in a real project. Have you seen any ABAP project, MM, CP, FICO, where entire functionality is in a single function module?
No.
No. Why? Because they modularized it. So how do you modularize OOPS ABAP? We create these classes and associate all these classes to make a complete system. Now some relationships are must have, some relationships are should have. So we'll see both examples. Let me create a plain class now once again. 38, or sorry, probably I'll go for an existing class which we have, ZCL plain. Now in the attribute section, we actually do the association. So right now I don't have any wing class here, or probably I don't have, an engine class. So let me create an engine class separately. So I say engine of operating. So what is the role of engine in a plane or in a car? Can anybody tell me what is the role of an engine? What are all the attributes of an engine, first of all? Any attribute? I just need two. Come on, fast.
Engine type.
Very good.
Capacity.
Engine type. Very good. Fuel capacity. I'll make as an instance public engine type, let's say KR10.
Engine power.
Engine power, very good. Very good. Power of engine. How much power it produces on per rounds per second, round per minute or round per second. Let's say info. There are lot many. Who is the manufacturer of the engine? What is the barcode? What is the unique identity of the engine? What is the size of the engine? Weight, height. What is the turbine size? What is the fuel tank size? How many wires are there? Thousands and thousands of attributes. We never club everything together in single class. Imagine if your plane is a very big class with thousands and millions of attributes of all the things. A single plane will have approximately 36,000 sensors mounted on it. All these sensors will control or will collect the data from different aspects when the plane is flying. So if something goes wrong, they can actually analyze the sensor data to find out what went wrong with the plane. There are more than 36,000 sensors mounted on a plane. Imagine all those sensors if I put in a single class, what will happen? It will become a mess for me. So rather doing that, I will divide all the components in separate classes and club all the things together with association concept. Do you really see a value here with association or not?
Right.
Right? So you're modularizing your pieces and connecting them together later. Okay, what is the function of an engine? Who will tell me? What are all the different functions of an engine? What an engine does?
Run
Come
the
on, guys.
plane.
Engine speed.
Okay, control
Rotations.
speed. So I'll say up speed.
RPM.
Start, start, stop.
Down.
Start, stop,
Very good. Start engine. It's a functionality.
stop.
Stop engine. Very good. There are a lot of them actually. You just need to visualize. You just need to visualize. That's it. It's all about visualization of objects. If you talk about a business object, sales order, now you will tell me 1,000 functionality of a sales order. Create, change, delete, edit partner functions, add item, remove item. All these are, there are a lot of them. You cannot even imagine that we can never end up bringing an object. It's always an evolution. It will always keep on enhancing. There is a never-ending development when it comes to of a class. Nobody can say my class is perfect. If you bring a single class in oops, I can still find out there must be some attribute into that. And that's very important to design. You need to know what exactly you're putting in which class. And that something which comes by an experience, little bit of experience and the right training. These two combination you need to actually design a software. Okay, so these are my some couple of engine methods. I mean, I would say very few methods. So I just put some code inside this. Just putting the right statement. I took the plain example because that's the simplest thing to understand. If I would have taken a ERP example, some of you are not from, let's say, FIN area or SD area or MM area, you wouldn't have understood it. So that's why I've taken a very layman term example called plain. So within this, I can have further functionalities which are very specific to my class. Let me show you one example. When you start the engine, the fuel supply will start. Okay, so fuel supply. Now, does my plane should know how should an engine consume the fuel? It doesn't need to know, right? It's a functionality of engine. Engine should take care how it has to consume the fuel, or how it has to move the gears, or how it has to change the RPM. All that should be taken care by engine, not by plane. So it's a private functionality to the plane. Plane only will take care. It's purely integral part of a plane functionality. So I'll say it right. So once your fuel supply will start, then only your engine will start. Now I will write the code. So in the start engine, to start an engine, what I should do first? Can anybody tell me what I should do? To start the engine, what should be the first step?
First,
Okay,
start.
think about car. It's your car. When you say start engine, what your car does? It starts supplying the fuel, right, in the engine.
Yeah, default like fuel will be supplied.
So I will call a method which is my private method called fuel supply.
Yeah.
Like this, we actually write the functionality. So here the complete responsibility is on the engine to take care of all the engine related tasks. Come back, stop engine. So like that you can have a stop fuel supply. So that's my subclass. Sorry, Do not call it as a subclass. It's not an inheritance. Remember again. It's not an inheritance. It's association. Let me show you how do we achieve now. So I go back to my plane class, ZCL airplane, and I'm going to put an attribute in this. In the attributes tab of the airplane, I would say engine or say ref engine. Ref means it's an object, instance private. See, do the passenger should know how the engine is working. As a passenger, do you need to know how the engine is working?
No.
Or as an airport authority person who is booking the ticket at airport counter, does he need to know how the engine is working?
No.
No.
Who needs to know how engine is working?
Pilot.
Inside the plane.
Only the plane. Even pilots don't know how the engine is behaving. That's why
Yeah.
accident happens. That's why there are crashes. If pilots have complete control on the engine manually, they can actually do it. The plane will know how the engine is working. So it's a private attribute. Only the plane will know. Nobody else will know how the engine is behaving. Plane will control. Pilot will know plane, and plane will know engine. Pilot never work with engines directly. They instruct plane and plane instructs engine. Am I right or wrong?
Right.
Good. Now it's an object. So for objects we use type reference to and the object name. So that's my engine class. That's how I associate. Did you get this part? How we associate an object with another object? Simply declare the object in the attributes tab of the object. In the plane now I will have an engine object. This is just declaration again. Type ref2 is just declaration. How? So we need to actually obtain the object. So when the object should be obtained?
In the runtime.
At runtime, very good. So whenever I create a plane object, automatically my engine object should be ready because without an engine I can't fly.
Yeah.
Right? So can anybody tell me which method gets called automatically when I create object of airplane?
Constructor.
Super, very good. So if I go and write my code in constructor to create that reference object of engine, whenever I create my airplane object, automatically object of wing will be created, right?
Yeah.
As a create object reference engine. So system will automatically create my engine object. So once my plane object is created, along with that itself, my engine object is ready. So if I see my plane object, it will have an engine object all the time. Right? This is called hard binding or composition. So whenever you have a composition, a create object should be written, must be written in the constructor of the class. Is this clear or not, guys?
Yes, yes.
Yeah.
Okay. Save this. Go back. So my engine is now ready. So now I let's say have a fly method here. So I want to fly. So pilot will call this method fly. Okay. Pilot will say fly. So what are all the activities pilot will do? First thing to fly, before you start flying, what is that which pilot needs to do? Think about your car, don't
Start
think
the
about your
engine.
plane. Start engine. So to start the engine, I need to write 1,000 things here. Rather than writing that, I've dedicated the responsibility to the engine class. So I can as well talk to the engine class and tell that please start the engine. And now engine should only take care of what should be done. So I've already have an object of engine class here, right? I have associated. So that's how I use it. And I call a method called start engine. See, all the methods are visible. So I set initial power to the engine, let's say 900 horsepower per tile. And then again I use me reference of engine class and start the engine. Now it's up to the engine how it starts. Whether it has to start a fuel supply, spark plug, all that will be taken care by engine class. It's not our plane responsibility. So now I can use start engine at 1,000 places. Let's say I'm doing flight testing. So flight testing also I can use this particular method. Not just an airplane uses it, even I'm just doing engine testing. I can just use this small method to test whether my engine is starting or not. So it's a reusable piece now, the engine class. I can use it anywhere. And then I will say, after starting the engine, start flying on runway. And then finally take off. So that's my code. Activate this. Come to the program. So I'm going to write a program now just to fly. Airplane object. So create object, airplane object. And hello underscore airplane, arrow, fly. That's it. So this is, let's say, pilot program. Pilot will say create an object of airplane and fly. That's it. Fly this thing. Pilot just need to say to the plane, please fly. I don't know anything else. Plane only have to decide that it has to run on the runway. It has to take off, squeeze the landing gears, shut off the emergency lights, switch off the signals for seat belt. All these functionality will be taken care by plane. Start the autopilot mode, choose the best optimum path, start all the sensors to record the data, start the black box recording, audio recording, flight data recorder, all the things is up to the plane class. It's not my duty. Plane will automatically do all that. Does pilot ever tell black box to record my voice? Never. He will never say, hey black box, can you please record my voice? Never. It's an integral functionality of a plane. Plane will automatically do that. Does pilot always say that please go, I want to fly above the Anubhav's house? No. Plane will decide the path. There are predefined air runways on which planes are always flying at a predefined height from each other. So that's how they do. Okay, let's execute this. I'll set a breakpoint. So first of all, my create object will be called, wherein it will call the constructor of my class. So you can see it is called the constructor of the class, which is creating the engine object here. The composite object which I associated with my plane, that gets created. Now it comes to fly. Fly sets the object attribute. It calls the method of another object. So you can see it has came to here. Now in this we have written the fuel supply method, which is the private method of my engine class. It goes inside, calls this functionality, which is engine class functionality, then comes to the engine class start method, calls this, come back, call the functionality for my fly method of plane class, execute. See, fuel supply started internally, engine started green from both the engines you've got. Now you can start flying on the runway, Roger, and it's a takeoff. So you can see the power of association. If you already have all the modules developed, you just need to, control those modules based on association. You link all the objects together and control with a single object. Here that object is the plane, which will control black boxes, autopilot, which will control, plane will control all of that. You don't need to worry about it as a caller. Understood the association concept, guys?
Yeah.
Yep.
You can actually apply to anything. Sales order. Sales order has materials. If I want to, schedule delivery of a single material, I will go to that material associated object and say release. So the clear responsibility on each object. That's oops. So this is what was the tight binding, the hard binding, where always you will have a engine object as part of plane object. Now I'll show you loose binding, where I'll create a passenger class. ZCL underscore passenger. Can anybody tell me the attributes of a passenger class? What are all the attributes of a passenger? Come on, guys.
Seats.
Some number of seats.
That's not passenger attribute. If you are a passenger, what are all your attributes?
Oh, passenger.
Name. Sex.
Very
Age.
good, very good, very good. Luggage. How much luggage the passenger is carrying? That's a passenger attribute, specific to one person who is traveling with the plane.
Yeah.
What is the region to which it belongs? What is the passport number? All these are entities. So you can see here, passport ID is the entity here. Attribute here for my passenger. It's a unique number for each passenger. Name, age, all these are attributes. Do you agree?
Yeah.
Yeah.
Now coming to the class, you can see set data method, get data method, print the ID of the passenger, cancel the booking of passenger. So some methods of a passenger class. Now you can see here constructor of a passenger class. So whenever I create passenger object, this constructor will be called. And I do have an importing parameter here, which is the ID of the passenger. A passenger cannot fly without passenger ID, right? Can you fly without your ID proof?
No.
So that's a mandatory attribute. So I always expect this to be passed when the object of passenger is created. So you can see I assign whatever ID user passes to passenger ID attribute. If the ID value is not passed, I am generating a unique number all the time. So that's how we give identity to a unique object. If passenger has not passed the ID, I will assign a unique ID from my side to the passenger. That's the part of code here. Any doubt on this code? Constructor code?
No.
So
This one is
now
like BRF plus function module.
yes, there is a standard function module, BRF function module, which generates the GUID for us, a unique number all the time.
Okay.
Okay. Now I have set data method, which will basically set the data like name and age of the passenger. Then I have get data method, which will just get the data for me from the name of passenger, setter getter method basically. Then I have a print ID method, which will basically print the ID of the passenger. Then I have cancel booking method, which will cancel the booking of a particular passenger based on its ID. That's a unique identification of a passenger in a plane. Okay. Now I will associate this object. It's a loose binding. So can anybody tell me how many passengers can be part of a plane?
N.
N number of passengers. Very good.
Yes.
So if I associate only this object, can I have N number of objects associated in my plane? How many engine objects you had just now? We are done with engine.
One.
How many?
One.
Only one we
One.
had, right? So if
Yeah.
I just put the passenger class here, can I have multiple passengers then? Multiple objects
No.
of passenger hold? No, we can't.
No.
So we have to create a table of passengers, right?
Right.
Yeah.
So we will create, how do you create an internal table in a bar? Using data dictionary.
Data internal table or
I
Table.
want to create an internal table in my ABAP program using a data dictionary object. What is the best way?
Table type.
Very good answer, Abhijit. Superb. I'll give you a point for that. We create a table type. So here we want to actually have an internal table of objects. So we'll create a table type. So let's say Z underscore TT underscore passengers. 1. Create a type as a table type, table of passengers. So when you have a structure type of internal table, you use line type. But I want to create an object internal table. So I choose reference type.
Okay.
And put my class name here. Now this will create an internal table of objects and each object will be of this type. Is this part clear? Here. It's an internal table of objects, just like you have internal table of structure. Copy this. Come here and say tab passengers, instance private of the table type. So this is another type of association which is called aggregation. It's a loose binding. I may have passengers inside this table or I may not have. Now I'll go to the methods and add a passenger, add a method for passenger. So add, I'll say create booking. So actually a passenger gets added to a plane when you create a booking, right? So to create a booking, what are all the attributes you need to pass on a plane website?
ID.
ID, very good, super. What else?
Name.
Name of passenger.
Passport ID.
That's ID only actually. Any ID you
Okay.
provide, we can actually book, right?
Okay.
You don't need exactly the passport ID. That's only you need for international travels.
Yeah.
Super. Now inside the create booking, what I will do? Whenever you call create booking, I create a local object of passenger class. Type ref to ZCL underscore passenger. And I create this object, local object. And if you remember, it has a constructor which will expect a parameter to be passed, exporting I underscore ID.
Right.
So I'll map the ID which I received from here to the constructor. Let me take you to the class again and show you the constructor. So you can see there is a parameter called I underscore ID to the constructor.
Yep.
Now I will set the data of my passenger. I will call this method multiple times as many number of bookings we need, right?
Yep.
So every time I call, my object will be created again, right? I'm saying create object again. So previously, whatever object I created, where it is stored? It is nowhere stored, right?
Right.
Okay, let me explain once again. I call create booking for Anubhav. It comes to this method, create a new object, set the ID of Anubhav, set the data. So the data is there in this local object. Now I try to book a ticket for Ravi. So I pass ID of Ravi, name Ravi, age, whatever. All that I pass, it again comes and create an object. So just before that, I created Anubhav object. That is gone, right? I don't have information about that.
Yeah, we have to append to that.
Very good, Ravi. Superb. You have got the point. So we will append this object, which we are creating, to our table, which is object table.
Yeah.
That's how same thing you do for internal table. If you're passing a structure every time you want, you will keep on appending to an internal table to the class. Now, I'll show you the power of association. Let's say I want to cancel one single booking. So what I will do, I will call the passenger method cancel booking. That passenger will say cancel the booking, fine. But if my flight itself got cancelled because of some weather condition, what will happen? I need to cancel all the bookings of my flight, right?
Yeah.
So what I'll say, cancel flight rather than cancel booking. I say cancel flight. When a cancel flight is called, what will happen? All the bookings inside that should be cancelled, right?
Right.
So what we do, we have all the passenger information stored with us.
We need to delete.
We will loop through all the passengers. We don't need to worry about how the cancellation is happening. We just loop through all the objects of passenger. And for each passenger, I will call in the loop cancel booking. Did you understood this?
Yes.
So that's the power of association. We don't need to worry how to cancel. We will tell that object, please cancel yourself. That's it. In the loop, whatever bookings we did, all that are there in this table, object table. Loop through each object one by one and cancel all the bookings. You can also print the names. You can print the ID. All that you can do. Let me show you. LOPass. I can as well call other methods of LOPass. Print ID. It will print the ID of passenger. Okay. Let's go back. Activate it. Ideally, I should have done this association with passenger plane class. Sorry, guys. I have not done it with passenger plane class. Instead, I have done it with a normal plane. It's a char 80 actually. The name is a char 80 parameter. Of not the one char 80. Edge is also not compatible. What is the type of edge? It's a 2-byte integer. I think integer 2 is suffice. I have put integer 1. Super. It is done now. Let's go back to the program. Okay. Now I want to create passengers. So what I will do? Hello airplane. Create booking. I will call. So pass the ID. Let's say S110. Name of passenger is Spiderman. And the edge of passenger is 33. I want to create one more booking inside my plane. Name of ID of a passenger is R110. Name of passenger is Robocop. Edge is 33. Now I want to cancel all the bookings. So I say airplane, cancel the flight, sorry. Let's debug and see what happens. So now passenger object will be created later point of time, not with the create object of airplane, right? It's a loose binding. Now I come to this method, create a booking. System calls this method, you can see. It has come here in this code. Creates a new object. The new passenger object is created, guys. I set the name and age of the passenger and append this to my table, object table. Again, one more booking. It comes, create another object, appends it to the object table. So if I show you your object table, it has got 2 records. Each record represents an object of passenger class. When you go to the object, you can actually see the data of that object. I'll take you to the second object. You can see that's my data of second object.
Mm.
Now I say cancel flights. So what it will do? It will loop through all the objects one by one, print the ID of the passenger first of all, and go to cancel booking. See, cancel booking method it got called. Now second loop pass, second passenger will be taken, that second object, loop through the second object, print the ID of that passenger and cancel the booking. See, that's the ID. Booking cancel for S100, booking cancel for R110.
Mm.
Any question?
No.
Now you can actually see the power of association here. It is
Mm.
not inheritance, I'm repeating. It's not similar objects. They both are different objects but working together to build your software. Okay. Now I can also do like this. I can create a local object here for passenger, hello underscore pass. Type ref to ZCL passenger. Create this object. We're going to pass a unique ID to this, exporting I underscore ID. Let's say I pass blank. So when I pass in blank, system should automatically create a unique ID and assign it to it. Because in
Mm.
constructor we have that code. Now I create a method in the airplane class, say add new passenger. That's another method which will directly add an object. So importing should be object type. I ref passenger. Importing type reference to ZCL underscore passenger. In this, it's very simple. My object is already ready-made passed to my class. I just append it. To my object table. Guys, again, you will never understand these concepts or remember these concepts if you don't try these on your own. Add new passenger, I called. Come here. This is the new object. I just say add this passenger to my pool. Pass the object to it. The passenger object directly. So what it will do, I created object in the class and that object I am passing to the method. Okay. That's another way actually doing it. Some people do with the old way, create booking wala. Some people will do with this way. Both are actually same techniques. Association. Now if you debug, it will actually create the object of passenger class here. You can see it has come to create object method of create object statement of passenger. When I say F5, it takes me to the constructor of the passenger class. Here I didn't pass the ID, so it will create a unique ID for you. A unique ID is generated and assigned. See, this is the unique ID automatically. Now I pass this object directly, it gets added to the tab passenger. So now when the cancel booking is called, there are three passengers. See, booking is cancelled for passenger having ID this. That's a unique ID which was generated. So that's another technique for association. Any questions? And when we pass an object in the method of another object, it is called delegation principle. So let me note down. Any question, guys? It's called delegation principle. In interview, people may ask you, what is delegation?
Can you write the definition for loose couple?
Okay, composition. It's a tight binding.
Okay.
Object must be created with so it's a loose binding, another one.
Yeah.
So can be created. Can be created with main object. But I can later on also assign it.
Okay.
So your passenger to plane is binding is 1:1 actually. So that's the end of oops ABAP here. From the next session, we will start on web to ABAP.
Okay.
Okay. In your next, okay, you can stop the recording if you don't have any doubts.